In today's lesson, we are going to look at two variable regressions. Now, we've looked at single variable regressions before, and that was basically where we were using Excel or using technology to come up with a line of best fit, or basically trying to come up with a line that best represents or best models the relationship of our data. So what we want to look at here, we're going to look at three different examples. And I want you to take a second to think about what do you notice and what do you wonder. So looking at the different graphs, it could be what you're seeing on the graphs, it could be what the data is, or if there's anything that just stands out that you're not too sure of what it actually is. Some things that hopefully stand out to you, or things that you might not know or might question, is what are these values? What are these R-squared values talking about? They're all kind of different between all three of my graphs. So is there some sort of connection between what those values are and what the graph shows? Hopefully as well, you're looking at the labels, and hopefully you're seeing that in this case, in our labels, we're seeing two different values, right? Years and kilometers, or kilotons, sorry. Hours on the phone, hours of sleep, male wage, female wage. So we're looking at different values or different variables. We're looking at two different sets of numbers. So that is what two variable analysis or two variable regression is. We're trying to see, is there a relationship between the two variables? Basically, as we're trying to see if one variable increases, does the other variable increase, or does it decrease, or is there no relationship at all? So again, we're trying to see how does one variable affect another. So in our examples here, looking at the number of years. As the years increase, does the total number of greenhouse emissions in Canada increase? And we have a line that models that. Oops. Looking at hours of sleep versus hours on the phone for individuals 15 years of age or older. So in this one, we're trying to see, is there a relationship between how much time you spend on the phone and how much or how many hours of sleep you get? You can see that there's a somewhat straight line, so you could say that as the hours on the phone increases, there's a chance that the hours of sleep also would decrease. And then finally, we're trying to see, is there a relationship between the average male wage and the average female wage? So you can see here it's fairly clear. There's a straight line that as one increases, the other increases, right? So you could say that there's a relationship there. That's the idea of looking at two different variables and trying to see if there's a relationship between them. Now, the other thing that we've highlighted, that R-squared value, that's going to be the main thing that we look at today in terms of two variable regression. And that R-squared value is going to be very useful. So the coefficient of determination, that R-squared value, what that is that it's a statistical measure of how certain you can be in making a prediction from a model. So we've talked about that before when we've used that kind of future plot or that extending of our line. Depending on what the R-squared value is, the more certain we can be in making a prediction. So if we're very strongly sure, or we're very certain that the line we've created models our relationship, then we can be certain in making a prediction, or when making a prediction from that model. So the key thing we want to think about is the closer the value is to 1, the more certain you can be. So if you have an R-squared value of 1, or very close to 1, the more certain you are that there is a relationship or something going on between the two variables. If you have a value of 0, or an R-squared value of 0, that would mean that the model is not reliable. So basically the equation that we've come up with, or the type of model that we're using, is not reliable and does not accurately represent the data. This could also be saying that there is no relationship between the two variables that we're dealing with. So if we were to go back up and look at the R-squared values that we highlighted in pink, we can see the one that looks very much like a straight line, the hourly wage, we can see that the r-squared value is very close to 1. This means that our data highly fits this model, and we can be very sure or accurate when making predictions. So if I wanted to predict what the female wage would be when the male wage is, say, 21, I can use that line to help me figure that out. And again, I would be very confident with that prediction based on the data we have. If I look at the total greenhouse gas emissions, we can see an r-squared value of 0.638. So again, it's close to 1, or it's closer to 1 than some other ones, but there is still some distance, and we can kind of see that in the points in our scatter plot. They don't quite form a straight line, but we do see that general trend or that general direction that they're heading in. So we could be fairly certain, but maybe not very certain, in making predictions based off of this model. And then lastly, looking at the lowest r-squared value of the three, 0.1167, so we can see that there is we're very uncertain about the relationship between hours spent on the phone and hours of sleep. And we can see that from our data because our data is very all over the place. It does kind of have a general slight trend downwards, saying that as the hours on the phone increases, then the hours of sleep will also decrease. But based on our data, we don't have a strong enough r-squared value to say that we're certain about that or that we're confident in making predictions. So it just basically means we either need to collect more data or maybe collect different data to kind of refine our searching or our analysis. Again, we kind of jump back. So again, looking at this set of data, this is basically, again, how or what your r-squared value could be. Again, the key thing is perfect correlation or perfect, you could say relationship or perfect certainty between our two variables is either at 1 or -1. Now you may have a -1, not so much with the r-squared values, but anything in either direction basically just means you either have a positive or a negative. As one increases, the other decreases, which is okay. And as one increases, the other increases as well. And again, we can see the change or kind of what you would consider it based off of 0.33 and 0.67. So again, those are kind of the dividing parts. So at 0.67, you could say we're moderately confident about the relationship. 0.33, you'd say, okay, we're not very confident or there's weak confidence. 0 would just state that we're not confident at all or there's no relationship. So let's go through an example of how to actually do this on Excel. So the example we're going to look at is credit debt. So we have basically our table here looking at the number of months and the number or the amount of debt that we've kind of built up over each month. So what we're going to do is we're going to go to our Excel online. So again, we've done this before in the previous lesson on regressions. Basically, if you go to your office.dsbn.org and go to your Excel app online, we can start to enter our data. So we're going to enter our table exactly as we see. We could type, we could put our month and our debt in dollars. So month we have 1, 2, 3, 4, 5, 6, 7, 8. And for our debt, $620, 761.88, 899.80. And again, all we're doing is we're just copying the table over. Into Excel. And the next thing we're going to be doing is basically now we're going to create our regressions and we're going to test 3 different models because depending on what the relationship is, there may be a specific model that helps match that or helps fit that better than the other ones. So again, to create a regression model, we've inserted our data. We're going to select it now. We're going to go to our insert menu. We're going to go over to the recommended charts and find the one for scatter plots. So again, it looks like this. We're going to click on that and we have our scatter plot. We have our number of months. We have our amount of debt. What we need to do now is we need to double click anywhere to bring up the chart menu. Let me move this down here. If we bring up the chart menu, we want to again go down to our series. So basically we're going to scroll down our format. We're going to go to our series. We're going to go to our options. We're going to click on the trend line because again we want a trend line. Now there's going to be three different options that we're going to focus on. We want either our linear, which we have there and we can see it lined up. We see the dotted lines that says linear. We want our linear, exponential, or polynomial. In other words, it's quadratic. Now, the other thing we want to do, we could display the equation like we've done before, and it gives us an equation, in this case a linear one, or again, depending on the type of trend that we choose. We also want the r-squared value. So the r-squared value is going to tell us the strength of the relationship. So we have our linear one of 0.9721. We can go to exponential. We have 0.997. And our polynomial one, 0.98. So again, depending on what type of trend we're using, we may get a different r-squared value. And that r-squared value is going to tell us the type of model that we should be using for our data. So it helps to have our table. So if we go back to our linear, we can see our r-squared value is 0.9721. If we go to our polynomial or quadratic, we can see 0.998. And if we go to our linear, or we already did linear, sorry, if we go to our exponential, we can see 0.997. So based off of those r-squared values, that would tell us, or we would choose, one of our models to best represent our relationship here. So between the number of months and the debt. So in this case, I would choose the polynomial or the quadratic. And the reason I would choose the quadratic model is because I have the highest r-squared value. So the highest r-squared value is what I'm looking for. Because it's basically saying I'm going to be the most confident in my predictions using that value. So I'm going to go back to polynomial. So has the highest r-squared value. So again, that's what I'm looking for when I'm creating these models. I'm going to go through and switch between all three of them. Again, the linear, exponential, and polynomial to see which one gives me the highest r-squared value. The highest r-squared value is going to be the one I'm most confident with based on the data that I have. And again, this could change between all of them. The more data I get, maybe it changes the r-squared value. So again, if I add more data to this, maybe the type of model that I use changes. But we're basing it on just the data that we have. So then your task going forward, you're going to be given a data set, or you're going to choose a data set, and you're going to go through the same steps as we've just done. Create a scatter plot, test the three models, linear, polynomial, or quadratic, and exponential. You're going to record the results, basically determining what the r-squared values are. And based off of that, which model best fits the data, or which model are you most confident in making predictions about the relationship. And that's going to be something that you're going to submit to D2L. But again, the main thing is from this lesson is just being able to go through, create a scatter plot, create a regression, one of the three different types, and enter the r squared, or display the r squared value to understand which one or which model you're most confident in to make predictions.